Alright, this is the quiz review that I'm doing. Both of these problems are actually from the first day of notes, but we only simplified them and stated the domain restrictions. So what we're going to do is do everything, including those things. So first thing you should do is always simplify. So that's what we're going to do here first. Again, you can take a negative 3x out on top, and you're left with a x cubed minus 8. And then on the bottom, you can take out a negative x, and you're left with an x squared plus 2x plus 4. Let's simplify it some more. Remember, this is the one we talked about where the domain restriction, this doesn't matter because it's imaginary solutions, so you don't have to include them in your extra restriction. The reason why I'm doing this problem again is you guys need to know how to factor difference or sum of two cubes. And that's what we're doing right now. Okay, so my domain restrictions are x such that x cannot be 0. And that's it. Vertical asymptotes. Let's look and see what happens when we cancel everything out. We cancel out these, and we cancel out the x's. So the thing that cancels out on the bottom is x as a whole. Then we have so we have a hole there. So there are no vertical asymptotes for this problem. For horizontal, the degree on top is higher than the degree on bottom. So if the degree on top is higher than the degree on bottom, then there is no horizontal asymptote. For C, we have to find the hole, and the hole is when x is 0. And we know that because that's what cancels out. So we look at what's left over when we have our simplified form, by the way, because we have to actually have our simplified form. And we get 3x minus 2. That's the most simplified this is. F of x is equal to that. And then we can plug in 0 for our hole. And when we plug that in, we get 0 minus 2 is negative 2 times 3 is negative 6. So when we have 0 for our hole, we get negative 6 for our y. Okay, so we have no vertical, no horizontal, a hole at 0, 6, and domain restriction just at negative or at 0. So let's look at the graph of this. I already put it into the calculator, so this is what it should look like when you enter it. There's actually some parentheses off screen, but you can look at it on here. And then when we graph it, that's kind of what it looks like. It looks like a straight line. And the hole is down here where x equals 0. So we can just graph that real quickly. And we know the hole's at 0, 6, and then it looks something like that. No horizontal or vertical asymptotes. Looks like a straight line. So we can do the range too. The range now is basically all y's such that y is not equal to negative 6 because there's nothing else here. It's open, and it's open all the way across. So that's everything that you can do on that problem. The key here is, again, the factoring and then the canceling. And when you have a quadratic on the bottom, you have to just make sure that there is no domain for those. And you can do that by just looking at this part in your graph. Look at this graph to see if it's imaginary or not. All right, now the second one was also from our notes. And again, first thing you want to do is simplify it. X plus 4, x plus 1, all over x minus 4 and x plus 4. All right, I have it down to this. My domain restrictions are x cannot be 4 or negative 4. Okay, the next step is to simplify and figure out if any of these are holes. Sure enough, those simplify. My simplified version is x plus 1 over x minus 4. And on the quiz, there might be a problem that only asks for that, so you could stop once you get it, and then the domain. But we're going to do the whole thing because there might be problems that have other parts to them. So, Now, because these canceled, this is a hole, and this that's left is a vertical asymptote. So, for A, my vertical asymptote is equal to x, well, you have to, and again, vertical asymptotes are lines, so the equation for the vertical asymptote is x equals 4. That's the important part. For the horizontal asymptote, B, the degree on top and bottom are both the same. Notice they're both x squareds. So the horizontal asymptote is then the lead coefficient ratio, which in this case is just 1 over 1. So the horizontal asymptote has the equation y equals 1. And we have a hole. Our hole is that the coordinate x is -4, and we have to find the y. To find the y, again, you go back to your simplified form only, and you plug in your x coordinate. So you get -4 plus 1 over -4 minus 4. So we get -3 over -8, or 3/8. So my hole is at 3/8. All right, so this, now we want to graph this before finding our range. This one I don't have in the calculator yet, so let's type that in. X squared plus 5x plus 4. And I forgot my parentheses. Make sure you have parentheses around the full top of your equation and bottom of your equation when you're typing it in, or else you will have problems. And then over, and this is x squared minus 16, I believe. I'll double check in a second. All right, so we have x squared minus 16, so let's look at the graph. There's our horizontal asymptote. It jumps up and it goes off forever. So it looks like a pretty standard graph. We can now graph this by hand. I have a vertical asymptote as x is equal to 4. So 1, 2, 3, 4. There's my vertical asymptote. I have a horizontal asymptote at y equals 1. So I'll dot that out there too. Remember, the horizontal asymptote is just for end behavior only, not for the middle of the graph. So if there happen to be a middle, remember when you have the middle of the graph and it goes all the way through, your range is all real values and it can cross in the middle. So we have a hole at -4 and then positive 3/8, which is below the 1, which means that this graph probably, and since we already looked at it, it's going to come through and down. So we have a graph that's going to do this, go through the hole, come down, and then approach that forever. And then we have the other piece of the graph come up here and go that way. And there's our graph. Since there's no special things here, the range is just all y values. But y can't be the horizontal asymptote because it never crosses it. So y can't be 1. And since there's no other value where the hole happens for the y also cannot be 3/8. Okay? And that should be all the information you need. And again, the simplified version is that, if I ask for that, domain, range, hole, vertical, horizontal asymptotes. Make sure that you have everything labeled, that these are correct. X equals for vertical asymptotes, y equals for horizontal. Your graph is relatively normal, and then there should be no problems there. And then finally, let's just make up a problem since I have some time left. I want a function that has, I don't know, let's make up something crazy. 2 vertical asymptotes, 1 hole, and I want a horizontal asymptote of y equals -2. Okay, so again, if I gave you a question that says write a function that has 2 vertical asymptotes, 1 hole, and a horizontal asymptote at y equals -2, you would first write f of x because we want a function. Then we'll make a fraction bar. I can make up any, I didn't give any special vertical asymptotes, so vertical asymptotes go on the bottom, and so do holes, so I need at least 3 things down here. So let's do x plus 1, x plus 2, x plus 3, because, you know, it's really creative of me, but 2 of those we want to make vertical asymptotes, 1 a hole. So if I want a hole, I need 1 of them to cancel out. So there we go. The x plus 1's the hole. These 2 are the vertical asymptotes. You don't have to label that if you don't want to on your quiz, but I'm just going to let you know that right now. I mean, I would know that myself anyway, but I'm labeling it on here just so you see where it came from. And this is our hole. Now, to get a y equal -2, that means the coefficients have to come into play. So I'm going to have a coefficient of -2 on top, and then you can just put a 1 on bottom. In order for that to work, though, I need the power on top to be the same as the power on bottom. Since we have 3 terms on bottom, we need 3 terms on top. You can just choose to finish this off by saying I have x squared on top. As long as it doesn't match any of these vertical asymptotes, you are okay. Okay, so x squared times x plus 1, and then the -2. And that is a function that has all the required pieces for that problem. And that was example 3. All right, I hope that helps you a little bit more. Again, if you see these problems, try them on your own first. Pause the video before you watch me do them. See if you can get all the information first. So, and then good luck on your quiz tomorrow.